All right. Welcome everyone to class. This is ODSA Fall 2025. This is SQL 101 Class 3. It's called Extracting and Storing Data. I also call it Storing and Managing Data. I'm Jeremy Bergman, the instructor for Omaha Data Science Academy. And tonight I call it either storing and managing data or extracting and storing data, because what you're doing is that you're taking often taking a data source when you're a data analyst, and then you're trying to determine what type of data structure, which in relational database is a table, can I most effectively store this in. So if you have a tabular data that's already in tabular format and it's transactional row by row, relational database is a perfect storage place for that. Data engineering, you'd learn more about different types of data and different ways to store it. But in this one, oftentimes it's extracting and storing data. I also call it storing and managing data because you're also storing the data. And then once it persists in the table, or once it stays there, once you have that data in the table, that structure that you'd like, you can do things like update records. You can update values of records in a field. You can insert new records into the table so you can add to that data, or you can delete data out of it. And I'm forgetting another one, but insert, update, and delete are three of the big operations that you can do. So once it's in there, you can also manage data. So whether you call it extracting and storing data or storing and managing data, I like both titles for this class. Okay. Let's go ahead. Gotta get my mouse over to the right spot. One second. I'll just do that. There we go. All right. So how is this class structured? So hour one, I had sent the class quiz out to the link into Slack. It looks like half the people have completed it. Try to do that as soon as you can. It covers the material over class 1 and class 2. We will learn about data definition language. So we briefly covered it. I want to take off. Does everybody see that StreamYard comment there on the screen?
Yes.
I hit some button. I want to get rid of it. Hide. There we go. Okay. Now I'm all set. Okay, so data definition language. So we learned about that in the first lecture as one of the main functions of a relational database. If you think about defining data in a relational database, you're really defining those containers that you store data in. So how do you create and modify databases or schemas? How do you create tables to be able to fit the data that you need? And then table constraints, we'll learn about those tonight. So defining what type of data and then what are valid values of the data that you can insert into the table. That helps keep the data consistent and clean. In the second hour, we'll do data manipulation language. So we used to call this data management and manipulation, because what you're doing is you're taking that data and storing it in a relational database to be able to use for analysis. But we brought in the term to SQL 101 in general. But data manipulation and management, or DMM, this would be inserting new data that I talked about, deleting and updating table data. So once it's already in there, what can you do with it? I will have a brief section on how you can import your own data sets into it. usually CSV files. And we'll talk about creating views tonight. Views are like virtual tables that you can do. You create a snippet of SQL code that you can reuse like a virtual table. We'll dive into that. That is really valuable in business intelligence, especially for storing queries that can be used for analysis or summarized correctly or have business rules that you already have baked into it. So hour 3, we will do examples and exercises. We haven't assigned homework 1 yet. Typically, once we complete homework 1, we do questions and review. But we'll cover some examples and exercises of data definition language and data manipulation and management tonight. All right. So review of the last class. So what did we cover? Just like to briefly do this, just to remember where we've been and where we're headed. Also can see if you have the class syllabus, you can also see it in there. You could talk about, we were talking about what are the common SQL clauses. So the 2 that are required, you have your select and your from statements. And then you have things like where, group by, having, order by, and so forth. What are the common aggregations and functions? Common aggregations are sums, averages. You do medians and modes, but not just aggregate functions, but you also have scalar functions that change single values in a table. Common aggregations, you always use the group by because you're taking a set of values and reducing it to something smaller. And you're usually grouping by different groups, like we grouped continent, population by continent in the last lecture. We found out how to utilize comments for debugging and explaining code. Use the pound sign in the code. You'll see that throughout the class. And then what are some various SQL function types? So aggregate functions, scalar functions, particularly on date and strings, where you'd use those the most. So really getting into the basics of writing queries. And tonight we'll talk about how you can take those queries or how you can take data and then manage them within the tables. So our objectives tonight will be to create and delete databases, create and delete tables and views, create tables with constraints. So constraints, like I mentioned, help with the quality of data that goes into the table. You don't necessarily just want everything going to the table. You want to make sure that it meets certain criteria. You can do that within relational databases by setting table constraints. You can add and delete table fields. So the number of fields in a table, you can add and delete you can add a new one or delete existing to make the table smaller or bigger. Widthwise, you can add or delete those table constraints, insert, update, and delete, and then import data from SQL into CSV files. So this image over here on the right side, I like using my cursor on this to point everyone to it. I can figure that out. There we go. It's just hidden when I was in the full screen mode, and I don't want to do it from the beginning. Just notice my cursor. Oh, there's my cursor. Kind of disappears when I do full screen mode, but I found it again, I think. So data definition language are those things: drop, create, alter. Whether it's databases, tables, think of those as like creating the canisters that hold the data. Data manipulation language or data manipulation and management, I called it on the last one, is once the data's in there, what can you do with it? All right, we'll learn all about that tonight. Those are the objectives. So what is the need for data manipulation? I just like to bring this along with us on our journey. We answered that what is the need in our first class. But here we're manipulating data and we're storing and retrieving it. So we're storing it for future uses in queries. So when would that be valuable? That'd be valuable if you wanted to store it, particularly if you wanted for a data analyst. I keep losing my cursor. For a data analyst, if you want to store historical data, you don't have to worry about having to always go and find it or go to what data source it lives in. You can just store that history in a table, and anytime you're connected to the database server, you can just query it. So being able to create these data structures and then store that data in it is super useful particularly when you're storing historical information or data. Now you can store a lot of things in there for analysis, but that's one of the most useful from our perspective. I keep hitting beginning on that. Okay. So very first, how do we create a new database in schema? So what's the purpose of that? The purpose is to create the container for persistent data storage and retrieval. So if that's not very descriptive, what you can do is create that database. And now once you create the database, I always think of that as like the coffee can. And inside of it's like the coffee. So you can now if you create the database, you can hold tables within it. You can hold views. And later in this class, when we learned about advanced SQL, we'll learn about stored procedures and functions. But now you can hold these tables or tables that have this historical data in it that you can use at any time. Or as we'll learn in views, you can hold cold code snippets. So you can create a piece of code, save it in a view, and then you can run it anytime, like it's a table, and then get those results. So it's like saving your query so that you can rerun it a bunch of times. So this is just an example of a database. We won't actually create the classic models database because I don't give everybody permission to create databases. But if you were to create it, you could create the classic models database is a retailer of scale models of classic car database. It contains business data like customers, products, sales orders, and so forth. So imagine a database of classic models, and then you have all these tables about customers and products and sales that you could go query and use for analytical purposes. So if you were able to do that, how could you do it? You could say, create database, classic models. So how I created your database is that bases that have your first initial and last name. I just said create database J Bergman, or I said create database C Mitchell, and then I just did that for everybody in the class. One thing that's useful is this use statement. So if you say use classic models or use J Bergman, what it does is that it points the database to what database is your active database that you want to use. So by doing this, you say, I want to be inside the classic models database, and that's my active and live database that I want to use. It's just a pointer. It helps keep track of, especially if you have long code, what database you're getting all your information from. And we'll see examples of that in this lecture. I just wanted to bring it up here right at the beginning. Okay. Get my cursor back. Okay. So now that we've created database, we can create tables, views, stored procedures, and functions underneath of it. Start by creating a table. So the purpose is to create that tabular structure for persistent data storage and retrieval. So you're creating that tabular data structure so that you can store tabular data in it. Oftentimes it's a CSV file, or you can think of it as an Excel file or something like that. Now you're putting it in a database to store it for lots of people to use. And now, since it's in a relational database, you can use the SQL programming language to get information out of it. That's probably one of the most valuable things if you're storing all this data in Excel. It can be hard to get to all of it. Now it's like there for everyone, and you can write command or code to say exactly what you want because all the data lives there. So what we're doing here is, that we were going to create a customer database. Instead of my schema, you could use your own schema and create this database. We define all of our table and field names. I have those in green. So in every table, you'll define a table name. So if you had a customers, you do customer number, name, maybe some of their contact information, like last name, first name, phone, so forth. You always define the data types that go along with it. So customer number is an integer. Customer name could be variable character of maximum length 50. So, of course, customer names are going to vary in length. 50 should usually cover it unless somebody has a super long first name. You could do phone, address lines. So phone we store as a variable character 50 because probably put dashes in it. City, state abbreviations, and so forth. So that's always the first thing that I define. Second thing I define is your primary key. So in every relational database table, you should have a primary key. And we'll learn a little bit why that's the case when we do joins in our next lecture. But one of the rules of relational databases is for it to work as cleanly and correctly as possible, you want every single row in your database table to be unique. So you don't want any duplicate records that tell you the exact same thing in your tables. And what the primary key is, it says what field will help us identify unique records. What field or combination of fields can do that? So if we have a customer number, say customer number 1, 2, 3, 4, 5, up to maybe 1 million or more, each one of those will make a customer unique or a row unique. So you're always second want to define some type of primary key, and then third you want to be able to get my cursor back. Third, you want to define some constraints on what values can go into here. So a lot of these things we just want, there's a not null, or you can say default null. By default, they'll be blank, or you never want these values to be blank. That's what not null would be. So, somebody was entering information from a web form, and they didn't include their first name. That record wouldn't go into the database because the database requires that the customer have a first name. And you'll see when you fill out forms on the internet, you'll have some required fields and not required fields. So with the required fields, those would be things that you'd say, we don't want any of the values to come into our database table that are null or any records. You can set default values. So you could say default state of Nebraska. So if somebody doesn't enter anything in, it'll default to being Nebraska. Or probably even a better example is you never want country to be null, and then you could default to USA. Or you can set numerical checks. You can check that a decimal. If somebody has a credit limit, that credit limit is never more than $1 million, or else something's probably wrong in the system. You can set numerical check constraints too. So we'll learn more. We'll dive into this the next slide. But know that there's 3 things that you do when you create these structures. You do all the table field names and data types. you do your primary key to help you identify uniquely each record in the table. And then you can, but it's not required, put constraints on those tables. So technically a primary key is not required either, but it's just like an almost necessary practice within relational databases to do that. Okay, so SQL constraints, talked about it in the last slide, but the purpose is you have two types of constraints. You have column constraints and table constraints. Your column constraints would be like those values that you put that you do or don't want, or by default want within the records in your table. Table constraint would be like a primary key, but you do both of these to prevent bad data from sneaking into your tables. So we just say analysis tables because in this class we're focused on SQL from a data analyst perspective. A practical example is building an analysis table. So maybe you're doing some survey responses. You just want the response ID, survey date, age, satisfaction score. So now you can create a table like this, but since it doesn't have any constraints, messy data can get into it. So you could have duplicate response IDs. You could have invalid dates, missing dates, maybe an invalid satisfaction score, right? So
Quick question on the constraints. Yeah. Sorry.
Yeah.
I see it looks like they're all data types, the constraints that are listed. Do you also use these constraints for formatting? So if you were looking up emails or your form takes in emails, you won't accept anything that doesn't have a format of @ and then some sort of domain name.
Yeah.
Or is that something separate?
Yeah, you can use logic in here. So you'd use something like a check, and then your logic
Got it.
would
Okay,
be here.
thank you.
So you could use, so this check logic, it just says the length is like, or the value is greater than equal to 0. So it gives you true or false logic there. That's what you would do with a email. You would see if there's like an @ sign in it.
Okay, thanks.
Not to go too far off the rails, but oftentimes you do this on the application side too. You'd write a rule that says it check in the form if you have a certain format. But it's also good to put these constraints on the database, just an extra layer of data assurance, data quality, and data assurance.
All right, thank you.
Yep, you're welcome. So you have these data types over on the left side. It doesn't have any constraints, table or column constraints. You technically can do this, but it sets you up for some challenges. But what you can do is you can start putting constraints on it. So you make it's your response ID of your survey, your primary key, making sure that's always like 1, 2, 3, 4, 5. It uniquely identifies the rows in the table. Your dates aren't null, so you always have a valid date for each survey. Categories are never null. You have a couple maybe different measures that you take out of your survey, like satisfaction scores, making sure that it's greater than 0, or maybe it's an optional metric, and if it doesn't have a value, you set it to 0. And then for the text. Yep.
For the check, can you can it be like a pretty complex logical statement, or can it just be a one line type of thing?
I was trying to think. I hardly ever write any complex constraints. If I'm doing that, I'm usually doing it on the application side. So I do a little bit of application development too.
Okay.
I was thinking about that. You can write like, you can use those operators that we talked about. Basically, I'm not sure how complex you could get with it. You can get really complex in the where statement, and you probably can't get that complex here. But you could do ands here, so you could check for more than one condition.
So then would it make sense to do stuff in like the view instead of doing it like in the table creation, like doing it like if like doing the cleanup stuff in the view?
Yeah, we actually learn about that.
Okay.
So that's one of the great uses of the view, is that you have like all of your cleaning. We will learn about that in lecture 5. Is using it. We introduced views today, but storing your business logic and your cleaning rules and case statements is like the perfect thing to do inside of a view, because then it becomes reusable when you define all of it there. Probably what I would do is, like, if it gets complex enough, is write a stored procedure that checks for like certain conditions. And if like a new value was inserted in, you can do things. You can do a whole bunch of things, complicated things with some more like programming like logic that we'll learn in the advanced SQL part of this class. I'd probably write it there, and then anytime a record's inserted, I would just call like a function or a stored procedure or something. That might not make that much sense to you right now, but I wouldn't write it. I wouldn't write complex like a lot of complex logic in like your check constraint on these tables. I don't even know how complex you could get with it. If it becomes complex, I would write it. I would think of something else. Usually like these things, right, are like you're just like checking a value. You're making sure that value is not null, or it's greater than 0. It's default. You set a default value and stuff like that. You're really checking the values. I'd have to think about how you would want to do I could think of complex logic, but I think that you'd want to do it somewhere else. I'd have to think about it. I would do it a different way. So for the advanced, like, that's more for the advanced people in this class. So probably confusing the people who aren't, but these are really just meant to be like simple checks of the values that are going in. And yeah, you get dirty tables all the time. You can clean them up inside the views, which we do in this class. That's one of the super practical applications of SQL for data analysts, or just even business analysts, or creating reports and stuff like that. Create a view to generate a report. So we'll learn in this class itself. I mean, this lecture itself. Right. Yeah. Just taking notes? Okay. You're welcome. No problem. I'll take a break here pretty soon. It's 7:18. I get through a couple more slides. We're about halfway through this lecture, so we'll take a break here in a few minutes, just letting in-person student catch up. Let me know when you're ready. Ready? I still like to write. I write notes in my notebook all the time. I'm just used to it, like from forever ago. It helps. I feel like it helps to write some of it, because like you're writing it and thinking of it at the same time. Yeah, I still do meeting notes like that a lot of times. Okay, so table constraints we learned about. Well, I went kind of into deep detail there, so we'll go quickly over table constraints. So table constraints enforce rules across multiple columns or the entire table to maintain data quality. So what it means, rules across multiple columns or the entire table is like this primary key. It enforces like the entire row. It uniquely identifies each row with no duplicates, and you can't have any null values for primary key. Another table constraint is unique. You can force a column to have unique values, and it prevents duplicates from entering that column. So if you prevent, especially if you're doing a unique primary key, you can ensure with the unique keyword that you aren't going to get like 2 1s for a customer ID. It will reject the second one. So it's like an assurance check on making sure the values are actually unique. And then check is like we saw, it enforces custom rules. You see, you can with check, you can do logic, you can do age between 18 and 120. It's kind of interesting that they do check as a table constraint. But the real world example here, you see it, you're defining the response ID for the survey as the primary key. Your response is your unique identifier. You check that the age is between 18 and 120. Satisfaction is between 1 and 5. That you have valid scores. And then you say, based on the unique combination of survey and responded ID, don't have any duplicate rows. And then your check, you can do a check on the response date, which here would have to be greater than 2024. 1-1. So you can, adding checks into this helps you have no impossible dates. So the benefits of table constraints, you have no duplicates, no invalid ages, ratings stay within scales, and clean data for analysis. So it tries to enforce these on values across the table. So your column level, I think that's the way to think about this too, is these table constraints are forces it across, it's forcing it on the rows. And then columns is up and down each column. What values can be valid in each column. So these constraints, column level constraints. So you have, and these are it's very common to put column level constraints for the values inside of the fields that you're placing in or you're creating in the table. Let me try to get my cursor back. And I think we'll take a break after this slide, after we're done with constraints. Okay. So very common to put like defining if the values should never be null, or you can allow nulls. And it allows nulls by default, so not null is probably the most common. You can set default values. Maybe you set a default value to unknown if you're getting this information from a form and they don't enter anything, so you just set it to unknown instead of blank. Status could be by default pending. That makes sense to do that. Transaction codes all have to be unique. And then your integer, you can do checks here too. So it's kind of, you have uniques and checks also as column constraints. So why each constraint matters for analysis. So not null, it prevents missing critical data. Like for example, it's often on a date field. You never really want a date to be null because otherwise you can't analyze sales by date without it. So your defaults, it fills gaps automatically, like unknown regions. Oftentimes when you're doing data analysis, you could group things into like an other or an unknown group. It's helpful to be able to see that. And then potentially fix it or just use that. Unknown provides information and likely provides information in itself. Making sure you have uniques. It'll prevent double counting transactions if you're doing summaries, so you aren't inserting duplicate records. Checks block impossible values that would throw off your analysis. And then your primary key also. Make sure that you have uniqueness every row, every database table, and decaffeinate up. All right, so covered quite a bit in that 40 minutes or so. Yeah, we'll leave it here while we take a break. Let's take a 10-minute break. So I can't decide between 10 and 15, so we'll go 12-minute break. I have the time of 7:26. Let's do 7:38, and we'll do the rest of this lecture. And then we have some examples at the end and some additional content. One thing I realized that I'm doing also is that I'm not running any of these examples, so I should go back and run these examples instead of just talking about them. So we'll bring up, when we come back, we'll go back and run through some of these examples in MySQL Workbench and see how you can create these in your own personal schemas also. Right, 12-minute break, do 7:38. We'll come back and then we'll go backwards and run some of these examples to see what they do. And they should also be in your MySQL Workbench in that PowerPoint SQL file. Right. Thought the rhythm was good, so I just kind of kept rolling and forgot about it. 7:38, take a break, grab a snack, and then we'll gear up for the last little less than an hour and a half. All right, see you then. Oh, I could move around.
I'm in class that feels like all
I'm wearing down too.
when you started yawning, I'm like, oh no,
Oh, I get it. I'm like busy and strung up all day, and then I sit here and I get relaxed for half a second. I'm like, start to yawn. I just do. That's the other. Just to get up and move. I was standing too long, but to get rid of that too.
I know, and they stretch.
Kind of stretch, but get the blood flowing a little bit. I'll be back in a minute.
Okay, sure. You stand.
I took a long walk, yeah. I hear you. Two. I'll be back in a minute.
Okay.
I won't be ready to go. All right, that helped.
You gotta get the blood flowing.
Where's that?
I say get that blood flowing.
Yeah.
in the face and stuff.
I'm gonna do some jumping jacks.
Mhm.
So that's just moving my arms. Needed a long walk.
It's cold on you.
It is a little cold in here. I charge up my phone and then we'll be. See how my laptop's doing. Charge up my phone and then we'll get going. If I have a couple things in private chat. What do we have in private chat? Celeste had a couple things in chat. I probably missed the opportunity a little bit. Yeah, check for email address is a good one. Phone number also. That meets a certain format. Could ask AI for a lot of things, of course. And does a pretty good job writing, at least. I think it's still with AI, it's still important to know how to write this code because you can tell when it's wrong, when something's not quite right. That's still important. We're not what you're looking for, and you can provide it better guidance. So it's still, right now, it's still important to have these programming skills. I think it'll be a while before it's perfect. It takes everyone's jobs. If that even becomes a thing, we'll see. Well, that's kind of off topic. Wes just mentioned AI. But yes, if you said create me a table with these fields and these constraints with something as a primary key, I bet I would do it almost perfectly. And do it basically perfectly for you. Or even asking it, I'm creating you can be kind of vague about it. You could be like, I'm creating a customer table. I'm thinking of putting these things in there, but what else should I capture or think about? Then I'll give you some suggestions based on things that other people have done and constraints and stuff like that. Which I'm talking while I'm eating candy. But usually why you wouldn't put really complicated things into your check procedures, I was thinking about this on my walk, is it's really meant as like a simple check of 1 or 2 conditions on a field and the values. What you can do is there are things called triggers we'll learn about in the advanced part of the class, is that you can write some logic underneath the trigger. So like a trigger would be like on insert or before insert, like do these things or check these things. And so instead, like you're always inserting or updating things, or you say on update, check these. You can write more logic with some advanced functions. Kind of where my head was at. You could do a stored procedure to some degree, but we'll see those type of statements in advance. And then it just monitors the table. So it just monitors the table, and then whenever that action happens, it'll do a check against it. Simone says, so we want to reject bad data then rather than have it in a table with bad data and then clean it up in a view. I'd say it depends on what you're doing. If you're creating a system in a form, you probably don't want bad data to like get into your system. Imagine, we don't talk about this a lot now in this class. I used to about SQL as like a backend for applications. It's called online transaction processing. I focus more on it for data analysis purposes, but in those transactional systems, it's really important for some values not to get into the system because it could cause havoc. In data analysis, probably not quite as important because you could always clean them up. And that happens frequently, especially it could be a valid data that the system catches, but you want to clean it up for whatever your analysis is. So it's not necessarily dirty. It's just that you are like changing it for whatever analysis that you're doing or creating a business rule or whatever. So I would say one of the things that is useful is still defining a primary key on your table so that you aren't getting duplicate data. But even in the class that I teach, there are ways to detect duplicates and eliminate duplicates. Creating a view. One of the challenges is it's probably if you're continuing to add new data to that table, it's probably still a good idea to, and you aren't doing it by hand, if it's like a feed, to reject certain values, because if your table's really dirty or the really dirty data is entering it, you're constantly writing more and more rules to clean things up. And maybe that's what you want to do, but maybe you just say, I just don't want these values in my table for analysis. Or like before you insert it, let me check it or put it in a different table. And there are actually, if take data engineering classes, we have tabular data structures that aren't relational database tables. So they're really flexible. They allow for like unclean or missing data and stuff like that. It's kind of valuable. So long story short, if you're like doing a data warehouse and you have super clean historical data, you probably don't want to insert dirty data into it. And you just want to eliminate certain values before it gets there. That'd be valuable for analysis. Or if you're joining it, if you know you have two tables and you want to join those two tables together, so having a primary key and making sure that primary key is clean is still important. But other data is probably not quite as much, because you could write views and stuff like that. So yeah, even my analysis tables, for flexibility's sake, I'll sometimes allow dirty data into it and just clean it up. Sometimes it's valuable to see what the system produces also. Maybe it's producing some new value all of a sudden. You can catch that instead of just rejecting it from being in the table. It kind of depends, I guess. Depends on your audience too. They tolerate dirty data or not. Or if you handle it on the back end. I'd say I usually just make sure the primary key is good. And maybe check for some values, some crazy values. But you can write scripts to do that too, where you can write a view. You clean it up. Thing is, yeah, I'm going on a long discussion, but if it's really dirty data, you find yourself writing like a whole bunch of views or a whole bunch of rules, like a case statement that's 100 lines long. Be a good time to only allow certain values into the table. Check them before you insert them for analysis. So I'd say a combination of both. I generally lean toward flexibility. I don't put that many checks on my tables for when I'm doing analytics, but I would if I was developing like a mobile application or something like that. I have a different creature system versus just for data. All right. That in a long way answered your question, Simone, kind of talking out loud on how I would do it. So one of the things I promised I would go back and let's run some code here. I didn't do that at the beginning. Got on my always finding my cursor. Let's go back and run a few of these things. So we still have to do updates and everything. And we haven't done inserts. Okay, so let's see how a couple of these things work. and everything else should be from previous lecture. So this is simply how I created databases for everyone. I just go down the list. I take your first name or first initial, last name, do create database. You aren't, like I said, you aren't able to do it because I don't give you permission to create databases on this server. Because if I did, it'd become messy. You'd have a whole bunch of students creating like their own databases all over the place. But then you could use this database. And then over here, what you'll see is where it highlights. You'll highlight J. Bergman. It's already using it, but it's just a command to highlight which database is your active database. So why that's useful is usually you would create a table. You do your schema name dot the table you want to create. But since our active database is J. Bergman, I don't necessarily have to have the schema name on it because it knows to create this table inside of the active database, which is J. Bergman. So let's go ahead and see how this works. You can try to create this in your own. You can do it one of two ways. I think it's always safe to do schema name dot table name, because you may be confused which database is the active database. So here we're simply creating a table with a primary key. Go ahead and hit run. And now you don't see it right away. But if you go here and you hit refresh all, you'll see a table called person in your schema with those fields and ID as a primary key. Your ID will be bold and underlined.
Because you created the table, you just showed up as a person.
Yep. So I put it in my database, the J. Bergman database, and then it created the person table. So it said inside of the J. Bergman database.
When you did the dot, and I mean, when you
Yep.
selected dot person.
Yep.
And, add, like, parentheses.
Yeah, and then the syntax is you have parenthesis there and you have a parenthesis closing it, and then a comma to end the query, or a semicolon to end the query. Okay. So we haven't really got into these, but you can do certain things. I'll just go ahead and do them. We're coming up, we'll do alter table. So alter table allows you to like add or remove columns. So notice we don't have the gender. We don't have the gender column in there right now. So our active database is J. Bergman. So this should alter that table inside of the J. Bergman database. And it, if we refresh, it'll add this field that's character 1. And you can put constraints on this and everything if you wanted to too. We're just gonna add this field. Okay. If it works successfully, you can always look down at this output. So that command works successfully because you had the green check mark. It didn't impact any rows because you aren't changing any row values or anything. You're just adding a column. So let's refresh. Now, if that was successful, gender should appear there, and it does. You could also, if you wanted to remove, you could do delete. Actually, it might not be delete in MySQL. What is it? drop. It's not delete, it's drop. And you don't need a data type there for that. Because you're just telling it, if you're getting rid of any of these data structures, you would tell it to drop the column or drop the person table or drop the J. Bergman database. It's always drop to get rid of a database object.
So we would
Delete would be for records.
okay.
We want to use drop. So if I use drop and I hit refresh,
So we would use drop if we want to remove.
Yeah.
And SQL.
yeah. So you saw that removed that column. You could also drop table person, and that would delete this table. So you could drop a table, or you could drop, I could drop J. Bergman. It wouldn't allow you to drop your own table. But you could drop a database also, or a view, or any data type of database object that's like a table or a column, basically anything you see in here. Function, stored procedure, view. It's your way of deleting these things out of a database. In a column, you use that keyword drop.
And you can also drop a column.
Mm-hmm. That's what we did there. We added it and then we dropped it. So before I run the rest of this code, we haven't done inserts or updates or deletes or anything. So I'll continue with the lecture and then we'll run this code as we come across it. When do you delete? When you don't want it any longer.
But there was a previous time you go off the drop.
Yeah, I just entered delete. That's what my brain was thinking, but it wasn't delete. The keyword was drop.
Okay. I just wanted to verify that.
Delete's for something different. So we'll see what delete's for coming up, but it's drop to delete, to drop tables or databases or any one of these objects.
Because I looked at my notes and I remember previously you had put in the text delete.
Yeah, no, it's drop. We'll see where delete's used for something different. Yeah, this will delete a record, so it doesn't drop a table or anything. You're deleting information. In my brain was telling me delete, but I meant drop.
But I'm on your own ground. Oh, is that?
We haven't covered that yet. We'll cover it here at the end of lecture. I'll get to it. Oh no, I confused by
No, I just
put in
remember
delete.
previous tables, I saw the word delete. That's why I was asking. And I just didn't. You saw that.
Yeah. Nope, that's okay. Where's my cursor again? There it is. Just panic until I find it. Okay, let's cover the rest of it. So we covered constraints. We need to talk about like modifying and deleting tables. We just did that. And then how to manage data and values within the table. Okay, we still have a little bit to cover here. We'll go from current slide. Okay, covered table constraints, column level. We actually just covered modifying and deleting tables. So we added a column to that table. What were we just working on? We were working on a customer table. You can add a column. Here's the syntax. It's usually safe if you aren't using, if you don't know what your active database is, it's often safer to just always just say, alter the table in the database dot table you want to alter. And then you can add how to add a column name. You can add column name with the data type. So in this example, that would create the column name field within this customer table. You can also remove that column or any other columns by you're still altering an object, so you're altering a table. So you're changing these objects. That's what the alter keyword suggests. And then you're telling it what to alter the table is what we want to alter. There are a number of things you can alter views and things like that too, and alter other objects. But we're altering tables here. Alter this table in the J. Bergman database, the customers table, and then drop the column name. It would remove that, as we saw in our example. Like I said, you can drop other objects. You can even drop constraints. You could drop a constraint on the table if you would like. So oftentimes if you did a table constraint, you could do the table constraint and you could give the constraint a name, so you could edit it or drop it later. And then if you wanted to delete a table, it's not the delete statement. You're still dropping a database object. So you're dropping a table. If exists is kind of like a safety word, so it would check if that table, customers table, exists in the active database, then you could drop table. So what would happen is if that table didn't exist and you just did drop table customers, it would give you an error. It'd give you a red mark and say that table doesn't exist, so I can't drop it. But if you do if it exists, it gives you just a little yellow marker in your output, and it says table didn't exist. So it's like a little safety keyword for whether the table exists, if exists. It checks if that object exists or not, whether it's a table or view or other type of constraint or whatever it might be. Okay. We're going to start talking about inserting values in the table. So we've done a lot about creating these objects, modifying and deleting them. So we've like set all of this stuff up for being able to put data into a database table. So there are 3 different ways you can insert database or data into database tables. One of them is that I call it a manual way of inserting values into the table. So you start with this syntax, this keyword, insert into, and then your name of your database dot customers. So we're still working in that customers database. And then you list all of the columns you want to insert data into. So this is like a manual way of doing it. And then you could use this value statement and then put all of those values inside of parentheses. So what will happen is this 103 value is going to go into customer number. It'll go into the same order as you define it at the top. The customer name will be this Atier graphique. Customer name will be Schmidt, or contact last name would be the third field, would be Schmidt. And you can see these down here also. But it follows each one of these that you defined in that insert into. So if you ran this statement and then did a select from customers, now you have 2 records. So let's go ahead and run this in. Let's also go ahead and run this in MySQL Workbench. And it looks like I have, because I'm in class 3 exercises, I have a different example. Okay, so we've created our customer table. Or have we? Let's go ahead and create our customer table. So we could just start here at lecture 6. Let's create our customer table. Then if we refresh, now we have a customers table in there. Now we have that container that's available for us to put this type of information into, customer information into. Okay. And we even defined it with some constraints and primary keys and everything. And credit limit less than $1 million. Okay, so now that we have that table created, you can go down a little bit. Lecture 3, slide 9, we're manually inserting values in the table. So we have our table name and that big field list, and we just list all of our values that we want to be inserted. Each one of these values, you could have as many records as you want. They're all separated by commas until the last one. All right, so let's go ahead and run just this part. So 2 rows affected. So 2 rows, we know they were inserted into the table. It looks like it was successful. I always just like to check it anyway to make sure all the values were inserted the way that you expected them to be. And it looks like they were. I could have shown it before and after too. It was blank before. Actually, I want to show you one thing. Say we violated one of our constraints and we had the credit limit, what was it, over $1 million? So that's just over $1 million. So what happens if we try to insert this record that violates our constraint? Let me find my cursor one more time. Yep. So it says when we tried to insert that record, there are various different error codes in MySQL, but usually they're fairly descriptive. So it says check constraint, customer check 1 is violated. I guess that customer check 1 was the check that the credit limit doesn't go over $1 million. So it doesn't even allow this record to go into that database table that we created. That's why it keeps the database clean if there are just some records that you don't want to be in there.
So you can't just add.
What's that?
You're not able to just add it in. Because I see when you try to put it through and
So we tried to insert it using this value statement, and it wouldn't allow us to do it because it was over $1 million. Yeah, and if you have a constraint, you couldn't even, there's no way to put it in there unless you dropped or modified the constraint.
you would have to totally reevaluate your constraint.
Yeah. Yep. And that happens sometimes. You do have the capability to go in and alter your constraints. Edit. You'd alter your constraint and then give it the name of your constraint, which this one was customer check 1, and then you would change the rule on it.
In order for it to modify correctly to
If you wanted to change it from $1 million, if you would change, be like, oh, that looks legitimate, we want it to be 2 million, you would change the check to 2 million. Okay, let's keep moving through these slides. My mouse. Other direction, maybe. Okay, there we go. Need to just bring, instead of my scroll pad, need to bring my regular mouse. Okay, let's keep going through these other ones. So 2 other ways you can do it. You can insert values into a table from a query. So in a very similar way, you could create a table with some types and, some column names, some data types, and some constraints. So remember those backticks? We just put those around all of them in this case. You could do them around all the fields if you wanted, but since date is a reserved word in MySQL, we just put ticks around that to avoid any confusion when creating the table. So that's why all those have backticks. So if you created a query for records to be stored here, you can create a query based off another table. So you can insert in the same way we inserted values in a similar way. Oops. Trying to move my mouse over there. So in a similar way, we inserted values manually. We would say insert into the schema name.table and then the columns that you wanted to insert. But now we can use a matching query instead of defining every single one of those values. We could select these fields from, if we had our COVID-19 database loaded up, we can do that. I don't have this database loaded up, but basically in a way we copied this data. We took it from the schema.table, and then we're just copying that data into this jbergman.us table that we have. And then when you select all of those, you would see date. And in this case, number of cases was number of COVID cases identified in the United States on 1/21/2020, and the number of deaths from COVID. So I don't have that database loaded, so I can't show you that example. I need to update that slide. But it's one way that you can insert values into a table you can do it from another table. Oops. I said that there are 3 ways of doing it. I'm missing one. There's a copy. Yeah, there's a copy table. Just have it out of order. So copy table. This is really good if you want to copy a table from the world schema to your own database. So in this example, you don't even need to define the table. So what this process would look like is you could use your database. So make that the active database and drop any table if it exists, jbergman.city. So drop any table in the schema that would already have the city name. And you don't even have to create and define the table. You can just say create table jbergman.city by selecting star from world.city. So what this will do, it'll read all the columns and data types from world.city, and it'll replicate all of that data structure and those field names and field types and everything in your own schema. So this is super valuable as a data analyst. So you don't have to write your queries off of a different database. You can just take a copy of that entire table and put a copy of it in your schema. So also useful for the rest of this class too, and because we'll go ahead and run this and show you why. Where are we here? Creating views. I'll do that. I can't forget it. Let's copy table. Create the COVID-19, delete records. Trying to find it here. We aren't in slide 4. I must not have it in here. All right, I'll just copy it out of the slide. I do need to make an update to this file with all the changes that I made and then get it out to everyone, but let's just go ahead. I'll copy and paste this out of here. Okay. So first part, we're going to use our database. So it's highlighted that. Notice I don't have a city database in here right now, but we'll go ahead and run this anyway. Drop table if exists, jbergman.city. So all it does is give me a warning. That's what I was talking about earlier. If you have the if exists, it doesn't give you an error message. It just says if you have the if exists, it gives you a warning and says unknown table because it doesn't exist. So that's okay. But now we can create a table since not in there. We can create a table jbergman.city by selecting everything from world.city. Let's take a look at world.city. So world.city looks like this. ID, name, country code, district population. With these data types, character data types mostly, and population is integer. Let's see what happens when we run this. Okay. It says it created successfully, selected all of those. So 4,079 rows affected. So it took all of the 4,079 rows out of this and put it in that table in your schema. Oh no. So if we refresh all, we should see that city table. We have all those same data types. And let's just select. We right click in, select rows. You can see now you have city data for these different countries in the world. So Netherlands, it looks like, and then population. It took everything in that table and just copied it to your schema. So useful for this query so you don't, or you can get copies of data from the world schema, or if you're doing some of the advanced work in this class, the Sequila database. So you don't have to worry about inserting or deleting or doing anything to these tables. You can just copy them over to your schema and alter them however you'd like. And if you mess it up, you could just run the copy table command again and copy it over to your own database. You can refresh it and copy it over to your own database.
So we
Yep.
So we have the ability to make modifications in our own schema.
Correct.
Yeah.
Yep. Yeah, the only reason I didn't, because the challenge is if like somebody messed up or hate to say messed up, but say they altered the table or dropped the table by accident in the Sequila schema, then it impact everyone in the class. And so if you copy the table into your schema, then you can do anything that you want to it by create table and select star from world and then select star from. It's just copying it into your schema. Then you can alter it or drop it however you'd like. Alter it however you'd like and drop it, or insert new records or updates. Anything you'd like to do. Always meant do that because it's a key point for the homework. Let's keep moving through. Keep moving through lecture so we can at least get to some examples today. There we go. We're almost there. All right, update existing values in a table. So that's like the update statement says, update existing values in a table, or the update statement updates existing or missing values based on known changes to the data set. So here's an example. Is now that we have those two records inserted to the customers table, the set statement within the update tells you which column and value to update. And then you have a where statement. So the where statement, if you remember, that selects the rows in a query. So with this update statement, it's selecting which rows to update. So in this case, we're selecting the row with customer number 103. Let me get my cursor back. Right, so customer number 103, which would be that first row that we inserted in the table. It looks for those city and state values and replaces it with Omaha as a city and NE as the state. So the result is changing the old record value to the new values specified in the set keyword. So we can easily see how this works too. We can go to our code. I am certain that this is in PowerPoint SQL. Here we go. So notice before that record, let's do 143. So notice record, customer number 143. The city name is Nance, has no state. So the country is France. So the update statement, we're telling the database to update this table, changing city to Omaha, changing a state to Nebraska, where customer number is equal to 143. So let's see what happens. We run it. Okay, so it says one row affected like we'd expect. Rows changed one, or rows matched one, and it changed one. So let's see what this table looks like now. Say just do select star, like the queries that we saw yesterday. Select star will just select all of your columns from jbergman.customers with that customer number. And now we see that record, instead of Nance, it's Omaha, Nebraska. Country's still France because we didn't touch that, but we just told it to update those two records and it did successfully. So now with a disclaimer, when you update values in a database or delete values, they're really sensitive operations. So imagine if you didn't have this, we forgot the where statement. Let's just go ahead and do this on this table. What would you think that this would do? So if you don't have a where statement, it's just going to try to do this to all of the records on the table. Oh, look at that. So I had forgot that MySQL It says error code 1175, you're using safe update mode, so it prevents you from trying to do that. I actually forgot about that. If you don't have a where statement, MySQL is going to try to stop you from doing that. So what if we do this? Where statement is greater than or equal to 143. You do that by accident.
But what if you did want to change every single row in the database? How would you do that?
Oh, I'd probably put some condition where it's true on every row, like I just did here.
Oh, okay.
So where that I know like all the values are going to be greater than 0. Just put that condition where it's always true. So if I then select, I'm just going to do select. Now you see, because customer number was 143 and 172, is true on both of those. It did it both on Omaha, Nebraska. There might be cases where you want to change it all. You just have to be careful, because if you have the wrong where condition, you could easily update lots of values that you didn't intend to update. I always hate to say panic before I do it, but if I'm doing something important, I always like test it to make sure it does exactly what I want it to do before I actually do it. Yeah. I almost thought you said trauma for a second. I'm like, yeah, trauma from doing it myself. From accidentally updating the wrong records or deleting the wrong records. We'll see delete here in a second. I think of my mouse cursor. Okay, get control of this thing. Okay.
So I see there it says,
Yeah.
Jay Bergman used something too. Why was that?
Over here?
Yeah, US2 of a 101. Right there. Why?
Oh, I must just have, I called this table US2.
Oh, okay.
So I must have created it up here. I didn't do this example.
Okay, that's fine. Oh, that's fine.
And I didn't name it the same as the world.city. I just wanted these three columns where the country code is USA. And I said I was just getting USA cities out of it and then check my results. Okay. Yep. So in the same way, you have delete from, and you don't have set values because you aren't updating any values. All you're doing is deleting that entire record. So let's 143. Let's delete 172. Okay, delete from customers. Because the key for both of these, the update and the deletes, is that you have that where condition correct. For the updates, to some degree, you're updating the correct the values the way you want to, those set values. But having your where condition, so you say exactly what rows you want to update or delete. It's just critical. And that's why MySQL doesn't like you to do it without a where condition. So you could see now all of a sudden that customer number 172, it is gone from the database after I did the delete from. So those are to be used with caution, particularly being very careful about that where statement. That is a good place where doing that, that insert into to copy your table. Copy that into your schema first and then run your deletes and updates to make sure it works correctly before you do it on the table that matters. It's my professional advice. I thought when I was young and I did it, I was going to be fired for it. It caused a lot of work, but fortunately they didn't fire me. They had a backup, so fortunately they had DBAs and backups. But when I did it, I didn't know that. Okay. So we also covered deletes. Okay, delete. What is a view? I think that, yep, this is the last part. So a view, we talked about, or we had somebody mention it in class, and I did at the very beginning. But view is like a virtual table based on the result set of a SQL statement. So the output of the SQL statement, that data, you can save it inside of a view, your SQL code inside of a view. And then you could query that view like it's a table. Then you could save this as an object. You can save it as a view in your database for future use. So very helpful if you have like a bunch of logic inside of it for data analysis. If you have business rules, groupings, like Maria said, if you do a ton of or if you do some cleaning of the data, we will actually do that in lecture 5 in this class. Use a view to do some cleaning rules. It can be really valuable for that. So anytime you go back into the database, you can just run that view, and it should be pretty close to how you'd want the data to be presented for, or how you would want it formatted for analysis. So I use views all of the time for getting the data that I want, or applying business rules, or maybe even feeding it into Tableau. So you could create a view exactly the way the data that you wanted to go into Tableau. You could connect Tableau to your MySQL database, load this view, and then you could create all of your reports and visualizations. So SQL views have the following properties. A view is a named derived table. So what that means is, remember when we did create table, in this case we're doing a create view, but notice that we don't have to do all of the we don't have to define the data types or the constraints or anything like that, because what you're doing is just taking the results from that query, and then you could call it from that view. So whatever the results are for that, saves it in the view, and then you could use it later. So you could just select the country like it's a table. So you can select country from that view that you created. And then if I just wanted certain countries out of this entire result set, so this one is like the countries in Asia, maybe I only wanted a few countries out of that, I could write another query that just gets India, China, and Nepal. So this view, one of the things that's important to know is that this data is not stored. It's not like it's in a table. You didn't define it in a table. It's not stored permanently. You're just calling it up on demand whenever you need it. So it'll take time to process, but it can also be useful instead of storing 100 tables for every like little report that you want to create. You can just create these views and run them on demand whenever you want. So let's go ahead and run this to see what it looks like, how you would use it, and how it's created inside of your database schema. Let's get over there. Yep. We don't do the unions till the next class. Oh, here we go. So if we wanted to create this view, you can create this in your schema, your own. I'm creating it in J. Bergman. I like to use this naming convention VW underscore because it just tells me it's a view instead of a table. Sometimes in some organizations, you do underscore table to tell you it's a table. Always like to differentiate views from tables. And here's the query. Underneath of it, it's just going to get all these countries in Asia. Exactly the way I name the view. And if I run this entire thing, let's go up to my schema database. So it's not actually going to be in tables now. It's a view. And I've already created it. So I'm going to drop this, as I forgot to delete it from the last class. Do a refresh all. So, okay, now we don't have it in my schema. But if I run this, just like you create a table, it says create view successful. You can refresh all. Seems to like to expand that table. So now you see the view countries Asia and that one column. So now I can use this view like a table. It's just a virtual table without actually storing all that data in it. You can select, I'm going to select that one country field that I created. I created it off the name field in this table and then aliased it as country. Now I could just call it in country from that view by its alias. My results are China, India, and Nepal because I'm just getting those countries out of this view. So view is kind of like how it describes itself. It's just a view of a table that you create, of another table that you create using a SQL code in these results. And then you could actually reuse that view to do whatever you want with it. Filter it or add more logic for a different report or import it into Tableau or whatever you'd like to do with it. For reports, it's super useful for reporting and saving your queries and then just going and running it instead of having to reproduce it or find the SQL file every time. Or if you have a slight variation of a report, you could just do a where and maybe you're selecting, if it has a bunch of columns in it, maybe you're just selecting a few columns out of it. So really useful for data analysis. All right, so I think that's actually the end of this lecture. Let's cover the things, the recap, and a couple of extra things in here. So class 3 review, we cover quite a bit of ground in these classes, all about data definition language. So if you're doing tables, creating database objects, even creating views, you can create view. You can alter a view with different code, or you could drop the view. Data definition language allows you to create, drop, and alter database objects like databases themselves, tables, views, constraints. We haven't learned about some advanced things like stored procedures or functions. You could even do that. Now, the data manipulation language, we learned that after break. So inserting new records, updating records, and deleting records. One thing I don't have that I have in the appendix is I'll show you really quick how you can import data from CSV files into MySQL. We used to do this for a project or for class project, but we don't really run class project. But if you have something that's in tabular format, especially CSV format, well, you'd actually want it to be in CSV format. You could do that. If you have it in that format, it's in a tabular like format. That's basically, I can zoom in on that. See if you have like ride numbers, dates, distance, miles, time. You can see all the values, just like we do in the insert statements. They're all separated by commas, which is why we call it comma separated value. This is imported very well into a relational database. So what you can do is import that using the file import tool. You can create a SQL file to do it instead, or do it locally, but these are probably the best instructions here. So you could take it, you can use the table import wizard. You can import that data, and then you have a data set or a table that has all that data that you had in the CSV file in it. And there are a number of resources that you can get free data sets from, but I'll just show you how to do this real quick. I don't really cover it too much now. I just want to show you how you could potentially do it, because we don't really use it in class too much. But if you go to your schema and you right click, you'll have the table data import wizard. I see it on my other screen. I want to bring it over. So I'll give you this import, and then you could browse for CSV file. Maybe I have a crypto file. Nope, I don't have a crypto file. Let's do, I have this say I have this US zips file that I wanted to import. It has all the zip codes in the United States. And what does this look like? So in Excel, it looks like a table. Has zip code, latitude, longitude, has a whole bunch of, it has a whole bunch of zip codes and like what the city is of that zip code. Let's see what else it has in here. Population, density stuff, some good information about zip codes, what time zone it's in. Okay. So I want to open that, and just to show you, it displays really well when it's in Excel, but if we open it up in Notepad, let me pull this file over. Simone, you said, I just saw your comment at 8:26, but you said there's a thing called rollback. And yes, there is a thing called rollback. You have to, on the SQL database, you have to make sure that it is active on your database. And whenever your incremental backups are set up, because you could have incremental backups from like a month ago that aren't that useful. Well, I guess yeah. So there's a limited scope of being able to roll back, but if you have the right settings and you have a good database administrator, they'll have rollback that you're able to do it. That's basically what they did when in data warehouse table, when I accidentally deleted some records, they just rolled it back to the previous save state. Say database administrators, that's what they make a career off, is people like me. But it's good that they do that. Oh, so I showed, no, here. Want to show you this CSV file, what it looks like. So it displayed well in Excel because Excel just automatically reads CSV files like that. Oh, come on. Where's my cursor? My cursor. I want to pull this here. Oops, there we go. I just moved it over to the other screen. Here's what this file actually looks like. So it has a bunch of values. It has all of these in quotes, just to denote the different values. And then they are all comma separated. Okay, so that's what the file looks like. So if I go back to this import wizard, I want to import that file. Okay, so it recommends a name for me. It says J. Bergman US Zips. Seems okay with me. You can create that name if you want, and then you could also drop the table if it already exists, like the command that we learned today. So it's going to look at your CSV file, and it's going to do the best job of guessing what data types it's going to be. So it thinks that zip is a text. I'd probably keep it that way because it has leading zeros. And you want to make sure you keep those in the database. You have latitudes and longitudes as doubles. You have cities as text. You can do other stuff in here. These data types aren't exactly like you would create in a database table, but it's close enough for it'll create like it'll use these text data types to create the table, which works okay enough. It works okay for importing. So it won't be perfect, but it will get your data into the database table. So you have things like population, integers, density is a double. It usually does a pretty good job of guessing these, especially if your data is clean. If your data is not clean, then maybe not so much that you're importing. And you may have a lot of trouble importing it. But in general, it guesses pretty well. It's going to create this table. It's going to work on the import. So data can be hard to get into a database, a relational database. You may have to clean it quite a bit before you do it. So what Python will be good for is if you extract data from someone else or a CSV file, you can clean it up a lot before you put it in the relational database. That could be a reason why you may decide to not create a database or a database table with a ton of constraints, is that the data is a little bit dirty, but you want to get it into a relational database table so you can start working with it. So I do that sometimes. Even an initial run just to get the data into the database table may leave a primary key off of it. Then I clean it up with something like a view, and then you could create a table and import. You could create a view with the clean data and take that data from the view and import it into a clean table. So there can be multiple steps. I call it extract, transform, and load. You're extracting the data from somewhere, transforming it the way you need, and then loading it into a database table. Or if it's advanced data engineering, it could be loading it into a number of different types of systems. That's basically what data engineering is. It's like SQL is just one of the tools in data engineering. They have a whole bunch of different formats and types of databases and how you process data, how processing and cleaning data and stuff like that. And then doing it at scale. So if you have a lot of it, how do you manage it? Anybody's interested? It's a lot. This class can be a lot, but yeah, this thing takes forever too. This import takes forever. Yeah. Zip codes, like 70,000 zip codes in the United States, something like that. Oh, this file doesn't have that many. It might just be like residential or business zip codes. But this data import thing takes a while, so that's why we stopped doing it in class. They're having a hard time importing data file, getting files off the internet, and everybody doing it at once and getting it clean enough for their projects that they could use it. It takes work just to get it there. Okay, so it's 8:50. I was going to take a break, but we're trying to do some exercises here. 10 class. We are right there. It's almost bedtime. I'm sleepy. It's my bedtime. Let's see. Let's bring up these exercises. Okay. Additional resources. What I have. That's for finding data sets. If you want to import them and play around in the database, feel free. It's what the database is there for. There shouldn't be anything that you do that like brings down the database or anything. But if you do, just let me know and I'll restart it. Guess it's not impossible, but it shouldn't. Especially just import it into your own schema and do whatever you want with it. Next lecture, we'll be learning about joins. So primary keys become more important to be able to take those primary keys and match them to tables and be able to blend data. That's what we'll learn about in the next lecture. And let's do some of these. So we have these exercises. So it's just taking, this might be an example of an assignment that we do for like the simplified version of lecture 3. I'll probably make it just a little bit harder than this, but just the basics to know how to create a schema, create a table in your schema, I should say. Name person with the following qualities. So you define some fields, primary keys, field constraints. Alter the table to include a gender field, so you'd add it. Inserting the records. Deleting a record with the last name Presley, you'd end up deleting this third record. That's where you'd use the where clause. Update the last name to the record that contains ID = 4. Change that to Crooks. So that would change, I guess, Tupac's last name to Crooks. Drop the column first name from the table and drop the person table from the person schema. So this pretty much does everything that we covered. It does an update, insert, delete, create table. You're creating table and you're creating table and column constraints. The only thing it's missing is views. I have a file that does all of this. I could send this to everyone for examples. I haven't decided if I want to make it into the homework yet or not. I'll probably do something on the world database. So I'll send this to everyone after class. So start by using our schema. Let's go ahead we're already using our schema as active. You would just change that to your first initial and last name. create this table person inside of it. So it won't let me do it because it says that table name already exists. You could put in that if exists, create table if it's, or if not exists. If you wanted to be safe about it. It just gives me a warning now. It says table person already exists. So I'm just going to drop this table so I can create it. It was already in my schema. Going to create it from new. Go ahead and keep that check on there. It's a successfully created. We just created these. ID is an integer. Last name, first name is variable character, 50th length. Age is integer. Primary key is ID. So making sure that each record is uniquely identified by person ID. Then you could alter the table. So let's go ahead and refresh. Sometimes you'll forget to refresh. It'd be like, oh, it didn't create my table. Make sure you always refresh. Then you should see that person table. It currently doesn't have anything in it. But then we want to add, go ahead and add gender field to it. It said it did it successfully, added gender, character 1. You see it hasn't showed up there yet, but you can hit refresh. And now you see that gender field.
So you just highlight it and then hit refresh and it creates the gender field?
Yeah, you could refresh it anywhere, really. You could refresh it up here if you wanted. I just right click, and even if you did it on tables or if you did it on your database, it'll refresh all anywhere. I guess for it to just refresh everything, you could hit it up there. Okay. No data in there right now. We queried it. We can insert these values. I just created this silly little exercise a while ago. So what I kind of like to do after I insert the values, is you can write a query. You could say select star from person. I kind of just like to click it and hit 100 or top 1,000 because it'll just write that query for you. But it sets this limit to 1,000 rows. And then you can see that works successfully. It's funny, I just realized something. Where did that go? Where you go? Person table. Set Elvis Presley's age to 82 like he's still alive. Okay, where was I? Distracted myself. Let's see, exercise. Okay, so we inserted those. So this is the error that we saw. Not really an error, that protective state that MySQL is in is that it says state updates, or it doesn't want you to delete records without a where clause. So you can select to set the SQL safe state. So you're setting a variable, a system variable inside the database. Say SQL safe updates is equal to 0. I wonder why we did that here. There must be a reason. I remember it. Let's see. It says you're using a safe update mode and you tried to update a table without a where that uses a key column. Okay, so it didn't like it that here's why. It didn't like it that I deleted, was trying to delete Presley, because since it wasn't a key field, there could be more than one Presley in the table. It could be like Priscilla Presley and Elvis Presley. And you accidentally, since it's not a key field, it's not necessarily unique. So on top of wanting a where, and on top of wanting a where statement, it wants you to use a unique value. Or it wants you to do this on key values. So like the last example we did for the customers inside of the PowerPoint just a few minutes ago, that ID was a key value. It was a key value that uniquely identified, and it still allowed us to do like greater than 100. So it really wants to protect you from like doing a delete on update on something that's not like a primary key. So if you could set safe updates as equal to 0, and then it would allow you to do it. If you wanted to turn safe updates back on, you could do 1. It's kind of actually good that it does that. Yep, if I turn it back on, then it won't let me do it. It's just a flag value. It's kind of good that it kind of is like trying to protect the user from itself. In Microsoft SQL Server, I'm pretty sure it does not do that because that's where I made my mistake. All right. Okay, so you can update the last name in the record that contains ID 4. So even with the safe updates on, this should work okay because I'm doing a key field in the where statement. Except I have missing persons on there. I want to do J. Bergman instead. I want to go to that table in my schema. And that works okay because even with safe mode, we're doing a where on a primary key field, a unique field. So it's very specific. It says, like, I'm going to update this exact field. That's what, and there's only one instance of it. I'm going to update this one exact record and where that record is equal to crux. It wants you to do that so you're only updating one record at a time, a key field. So if I were to now do person, instead of 4, now we have 3. We deleted it with ID equal to 3. Now we just have 1, 2, and 4. Let's see if we had anything left in there. 902, we pretty much did it. You can drop the column out of the table. I just do the same J. Bergman, or since it's your active, since you set the active schema to your database, should just be able to do this. Dropping the first name. Hit refresh. Yep, now first name's gone out of there. And then you can even drop the table. So we'll drop the table. So actually the basics version of the homework will be something like this, likely. But we'll do it on the world database. It's just making sure that you go through each one and you can alter table, drop table, do updates, and the things that we learned in each class. And I'll try to do something like progressively more difficult, possibly. I really have to think about the design, but now we no longer have the persons table inside of the schema. So that was a quick version of that. We got through it.
Yeah.
We did it. I was mostly skeptical of myself.
I'm pushing myself.
I wasn't going to fall asleep. I hope everybody learned a lot, and we covered a lot at the beginning of class too, so we did really well on time today. I'll get out a designed homework one as soon as I can. I know I always say that, but I need to explain how I'm thinking about the class and want to design the homework for different skill levels. Covered quite a bit of ground here in the first 3 classes. It goes pretty fast. How I need to get it, just homework out so everybody can start practicing the skills. So class is dismissed. If you have questions, I'm always here till 9:30. Let me know. Or just want to chat. That's fine with me. It's a recording too, so it'll be on the YouTube channel. About 30 minutes. Takes about 30 minutes. And I'll work to download it too, so you have downloadable version. So you can always watch back over it. Can't remember something. Which is easy when we're cramming this much information in.
And it's different, like visualizing and actually.
Mm-hmm.
Because the first 2 days, I was lost. Today, I returned.
Yeah. No, yeah, I rethought it and did some updates to this, and I thought I was better as a teacher today too. How I wanted to go, an approach on how I wanted to go through the class today. Good, it worked. Yeah, I know. Then eventually, I just have to get my hands on something I'm learning how to do. Claude Code right now, so using AI to generate code, and it's a lot.
That's very
So
and AI is really expanding rapidly. You have a good weekend. I'll see you on
yeah,
I can't see my eyes
I
open.
know. I hope I don't fall asleep driving home. I won't have a short drive. See ya. All right, so I can finish this up. Can do outro. Let's do the outro. Okay, so this is the end of class 3. It's extracting and storing data, or also extracting and managing data. I am Jeremy Bergman, the instructor for the Omaha Data Science Academy class. The next class lecture we'll be doing joining and merging data. It'll be class 4 in SQL 101, fall of 2025. This is where we start taking data from 2 different tables or multiple tables and blending them together to create unique data sets. Either blending them together, joining, or appending and merging data. So tables with same columns, you can put those together to make an extended query or output, or even 2 different outputs to make an extended output. So I'm Jeremy Bergman. Once again, Omaha Data Science Academy. I will see you next time. Oops. We will see you next time. Thanks.